This chapter presents an environmental education program titled Global Environmental Challenges and Sustainable Solutions. The program aims to make students more aware of their environmental footprint and to encourage environmentally responsible attitudes and actions.
Environmental problems are becoming increasingly urgent. Climate change, biodiversity loss, pollution, resource depletion, and unsustainable consumption patterns affect ecosystems, communities, and future generations. Environmental education connects science, society, creativity, and action.
Constructivist and socio-constructivist learning. Students build knowledge through inquiry, collaboration, and real-world problem-solving rather than passively receiving information. Inquiry plus collaboration plus real-world problems equals transformative environmental learning. Educational implications and learning. Outcomes. This program follows an interdisciplinary curriculum design framework connected to citizenship and development. It combines scientific knowledge, practical skills, and active participation. Core environmental concepts: Earth, systems, carbon cycle, and water cycle. Students should understand Earth as an integrated system with interconnected cycles and processes. Ecosystems, climate systems, biogeochemical cycles, and biodiversity are all linked. Biodiversity supports the functioning of ecosystems and provides essential conditions for human survival. The more species and habitats are protected, the more resilient the planet becomes. Reflection. Which ecosystem service do students benefit from every day without noticing it?
Project-based learning is an educational approach in which students learn by actively exploring and responding to a meaningful question, problem, or challenge over an extended period of time. Instead of mainly receiving information from the teacher and reproducing it in tests, learners investigate a real or realistic issue, make decisions, collaborate with others, create a final product or outcome, and reflect on what they have learned throughout the process. In project-based learning, the project is not simply an activity added at the end of a unit. It is the central structure through which knowledge and skills are developed. This approach encourages critical thinking, creativity, communication.
Students conduct fieldwork to test water chemistry in local streams, reservoirs or other water sources, integrating chemistry, biology, and geography. Students assess the school's energy consumption, waste, generation and transportation patterns. They use data analysis and physics calculations to estimate carbon emissions and design reduction strategies. Project-based learning becomes stronger when students collect real data, analyze it, propose solutions and present their findings to a real audience. Connect each project to local and regional environmental contexts before scaling to global issues.
Teachers are encouraged to approach environmental education through practical, interdisciplinary and action-based learning. Assessment rubrics can be used to evaluate students' knowledge, inquiry, critical thinking, collaboration and citizenship action, while learning activities should begin with local and regional environmental problems before progressing to global issues. Environmental topics can be connected with subjects such as biology, geography, physics, chemistry, mathematics, arts and citizenship, helping students understand environmental systems, cycles, climate, biodiversity, pollution and resources in a broader context. By using data, fieldwork, experiments and creative communication, students are able to engage more actively with real-world problems and develop realistic actions for their school and community. This approach supports STEAM-based and project-based learning, while also developing 21st century competences such as critical thinking, problem-solving, collaboration, systems thinking and active citizenship. Overall, it transforms environmental awareness into meaningful action with local impact and global relevance. As a conclusion, this program provides students aged 12-18 with scientific knowledge, critical thinking skills, and a strong sense of responsibility toward the planet. Through biology, geography, physics, chemistry, mathematics, arts, and citizenship education, learners understand environmental complexity and discover concrete ways to act locally and globally. By the end of the program, students are expected not only to recognize key environmental problems, but also to participate actively in designing and implementing solutions at school and beyond.